started. I'm Veronica from Ocean Protocol, and the purpose of this meeting is to go through our Predict ETH workshop. The Predict ETH challenge that Ocean Protocol has started is a challenge to predict the price of ETH for the first 12 hours into the future. Let's get started here by introducing all the participants, and then we'll go through the README for the challenge and a quick submission example. We'll have a Q&A twice during the event, so if you have any questions in between then, go ahead and just those in the data challenge channel so that we can get to those as quickly as possible if those are outside of the Q&A. So with that, we've got Anna here, who is our Scrum Master. We've got Alex, the VP of Engineering. Trent is one of our co-founders. Jamie and JP are also here from Ocean. Let's get started. Trent, would you like to walk us through the README?
Sure, my pleasure. Hi, everyone, and welcome to this AMA event on the Predict ETH Challenge. I'm going to just share my screen here. Okay, so I'm going to start off by just going through the README, and then we can have questions at the end if there's any issues, etc. We'll work through those too, and I'll just walk through the README, but then we'll go from there. Yeah. So can everyone see my screen? Okay, great. So first of all, this is the top level of the READMEs for the Predict ETH Challenge. It's a specific repo within the Ocean Protocol GitHub. And for everyone's convenience, I will actually share a link here in the chat of this event too. So here's a link to what I'm going to. So let's just walk through this. Overall, it talks about the challenges at the top level, and this competition is to help show data value creation flows, how data can be used to create value. And one example of a data feed that would be particularly valuable is ETH price of the future. If you can predict the price of ETH accurately, you can immediately create value from it by buying or selling ETH, or for more advanced use cases, such as quantitative DeFi trading, yield farming, or even developing DeFi protocols. The challenge is, how accurately can you predict the price of ETH? And so this is the second such competition. We had the first one that started about 6 or 8 weeks ago and concluded a few weeks ago. So this one is round 2, and we will continue to have rounds of this going into the future. And as an overview of this top level README, we have the current challenge here, but then we also give examples of end-to-end flows, some example data sources, and so on. So I'm just going to walk through the challenge because this is the main thing to work from. So Predict ETH price round 2. This README describes the flow to predict future ETH price via a local AM model. It's used for, this second ETH prediction challenge, and it just got announced. So the kickoff was yesterday. We announced it, and competitors have 4 weeks basically to compete, in which case the deadline for submissions is at 1 minute before midnight of December 12th of midnight. So it's December 11th at 11:59 p.m. Universal Coordinated Time. And the predictions you have to make are basically from 1 hour in advance of the deadline, 2 hours in advance, 3 hours in advance, etc. And then we will see those results, the predictions, and we will calculate the error. We will wait 12 hours plus, of course, calculate the errors in the predictions, and then give rewards accordingly. There are a couple constraints and a couple benefits. So overall, the one constraint is your prediction error has to be better than a constant. So if you predict with just a constant, then constants can do pretty well, right? But if you predict with just that, and we will be comparing against a constant and seeing the error from that, so your prediction has to be better than that. examples. They show example predictions. They're quite simple right now. They're not deeply involved or anything. So your predictions have to be better than those too. So of course, if you want, you can take any of those end-to-end examples and use those as a starting point. But you're going to have to come up with your own improvements above and beyond, with more data, using data differently, better modeling, etc. So that's just a couple top levels. But if you do a submission and you meet these two constraints, A and B, then you will get a reward of 250 Ocean just for participating. And but it has to include a valid submission. So now what I'm going to do is walk through the 4 steps. Basic setup, getting data locally, making predictions, and publishing and sharing predictions. This README is on purpose very bare bones. So you'll see down below that making predictions is just random, because what we want to do is just show how to go end to end. And of course, though, getting data locally and making predictions, you can do much, much better with that. Okay, let's go through. So first of all, for setup, this is basically set up using OceanPy, the Ocean library that is the Python version of the Ocean library that uses Ocean smart contracts and other Ocean middleware for publishing assets, consuming assets, etc. So that's the basics. So in this, I'll just be very quick, but what we can do afterwards is, in fact, maybe I'll even do this as we go. I'll just do this as we go. Maybe it'll be easier. Well, no, I'm just going to go through, sorry. And then we can walk through later. So basically, installing Python has a few things. Installing the Python libraries, etc. So first of all, you create a virtual environment. So standard Python command to create this virtual environment. And then you activate it with this call. And this is very standard for any time. And then the main thing is we're going to be installing OceanLib. And but sometimes with OceanLib and other libraries, there can be some installation issues. So the first thing before installing OceanLib is installing Wheel. And by doing that, then it ensures that other libraries are installed with fewer issues, if not zero issues. So OceanLib, we're also going to be using a few other libraries here. Matplotlib, which is for plotting. It's a standard library in Python for plotting. PyBundler, this is a wrapper of Bundler, and Bundler is a wrapper of Arweave, a permanent storage network. We'll be using Arweave to store the final predictions on chain in a tamper-proof fashion. So PyBundler is a way to make that where it's a single line Python code to do so. And PCXG, this is a library that's out there to grab data from across 40 different exchanges with a unified API. And they've got a unified API as an HTTP API, but they also have a Python library. So we're using the Python library here. So in this single line call, we are using installing all these libraries. Now, one thing, PyBundler itself also needs a second thing installed. It's not automatic, which is the Bundler network client, and that's what's going on here. So you have to install this as well. Okay, so that's the first step. The next step is we're going to be doing everything in Polygon here. When you do your submissions, I mean, everything before you can do however you like, but when you do your submissions or your predictions, it's going to be on the Polygon network. Polygon is an EVM-based network. Think of it like a sidechain to Ethereum mainnet, and it's got very deep support for test nets, full nets. It has its own token instead of ETH as the main token. Its token is Matic, MATIC. So you have to have your own Matic to do the transactions, but the transactions tend to be very cheap. 1 cent, 10 cents, or so. So what we have here is we give a link to getting that information. I'll just jump to that. So this is from Polygon's main webpage, and it's focusing on the Matic token, and it describes what it's used for. It's used as the gas token to pay for transactions. It's also a proof of stake network, so it's used for security and governance. But then below it tells you where you can buy and sell Matic. So you can buy it from many different decentralized exchanges, as well as centralized exchanges and more, such as Binance. So for example, you could go buy Matic tokens on Binance and then send them to the Polygon network. And that way you have Matic, and that's pretty common. So if you have a centralized account in any of these, that's a pretty clean way to do it, because then you can send the tokens directly. So that's where to buy and sell Matic. So once you have $1, $5 worth of Matic, you don't need a lot, then you'll be back to here. Okay. Then the next thing is when you're going to be publishing your predictions asset in Ocean and also paying for your transactions to store in Arweave, you need those Matic tokens, and you're going to be storing those tokens in a wallet here. I apologize for the background. Sorry, background noise. So you're going to be storing you're going to have your own wallet with its own private key. You have that from above a Polygon account. If it happens to be a hardware wallet, then we recommend the simplest thing to do is send some Matic tokens from that hardware wallet to a wallet where you do have a private key directly, something that just more of a hot wallet that maybe only holds $1 or $5 worth of Matic to play with. That'll be the easiest. There are other ways to do this stuff with the hardware wallet directly, but it's much more involved. So this is by far the simplest. So, what we're doing here then is saying, in the terminal, you export the remote test private key. So this is your Polygon private key, but you're storing it, you're creating an end var just for that. And we will be using this end var, environmental variable below. The next thing is, we have a bunch of helper functions to help you do things like calculate test error, like load Ocean, etc. And we put them all into the appendix so that you just do it once at the beginning of your README, and then it's there for good. If you want, of course, you can copy and paste that into a script as you want. And I will just go below to show what that looks like. So this is an appendix of helper functions. And here, the first thing you do is, start a Python, and then you're going to copy and paste everything below. And so a bunch of imports at the top, date time, matplotlib, and some stuff from Ocean and Brownie. Brownie, by the way, is a third-party tool that allows you to connect to Ethereum-based chains very readily and interact with them with Python directly. And we're big fans of Brownie. We just recently switched over OceanPy from using Web3.py, another EVM library for Python, to using Brownie directly, simply because Brownie gives a lot more functionality. One of the key things it does is it converts every single smart contract into a Python class, and every single deployed smart contract into a Python object. So when you're in Python, you get to interact with Solidity deployed contracts, EVM deployed contracts as Python objects, which is really, really nice. For example, let's say you've got a data token, it's an ERC20 token. You can say, data token, let's say it's in Python, you can say data token dot name, and it gives you the name of the data token. And that's an ERC20 method. And all the other ERC20 methods too, like transfer and all the other ones basically are available directly as Python methods on top of the Python object. So the summary is that Brownie is a very powerful tool. It's a third-party tool library, Python library, that allows you to interact very cleanly with Ethereum smart contracts very nicely. So we use it extensively. And you'll see examples in here. So that's Brownie. Keeping going, so going back at the top here, we're in the appendix, we're talking about the helper functions. In these helper functions, we have a few different types. First of all, we have a couple of helper functions around Ocean. One is to simply create an Ocean instance. What it does is it grabs a config. A config is just a dict. It's very simple. It used to be more complex in Ocean 6 weeks ago and more. We made it much simpler, so it's just a dict. And it's stripped down. Anything that belongs in the Brownie config stays in the Brownie config. The next thing is we just have one. We ensure that it's one block confirmation rather than 3 or 5. It's just fast, and that's all we need. The next thing, it connects to the Polygon network. And that's just a simple helper function. And then it creates an Ocean object. The Ocean object knows about the networks, and we return that. So that's creating an Ocean instance. And then there's creating an Alice's wallet. So this is simply a Brownie wallet, or a Brownie account. And so it grabs this remote private key that we defined earlier that holds your Matic, right? $1 or $5 worth of Matic. And then from that private key, it simply creates a Brownie account. And then it also checks to make sure that you have at least some account there. So it'll complain if you don't have any Matic right here, right? So if your balance is 0, it'll tell you that you need some of that. and then it returns the wallet. The rest of this I'll just gloss over for now, but we have helper functions to convert a regular Python date time to simply a Unix time, which is a timestamp, and back. So exchanges often give information in Unix time, which is the number of seconds since January 1st, 1970. And exchanges actually do it as the number of milliseconds, so multiply that number by 1,000. So we have a way to convert back and forth to that, as well as in array format, and that just makes our life much easier. And some other time-based functions, as well as some information from loading data from exchanges. I won't get into the details here, but you can look for yourself. And loading and saving files for your predictions, calculating the error, whether it's test error or training error. Basically, y is the real value and y hat is a predicted value. And then, so basically gives you the normalized mean squared error. And then finally plotting the prices. So I'll show the usage of this above, but this kind of gives you a feel. Plotting the prices basically shows you x-axis is time, y-axis is the predicted value and the real value, and then you can see, in a qualitative way how you're doing. Okay, so going back, we just went through the helper functions, load the helper functions. Now that we have those, the rest of this README can be quite compact, and in many cases, a helper function might be used 2 or 3 times. Okay, the next thing is setup in Python. So all those helper functions, they just created functions, but we didn't actually instantiate anything yet. That's what we're going to do here. So the first thing is we call the helper function to create an Ocean instance, and it creates the Ocean instance, this object, right? And under the hood, it's connecting to the network. It's instantiating the Ocean object, passing in configure information, etc. Also, we're creating Alice's wallet, and like mentioned before, that is simply a wrapper for the private key, and it's a Brownie account. The next thing is you get data locally, and you can get whatever data locally you want, right? And we in this simple README, we don't even bother showing anything because we don't want to get in the way too much of that. But I'll just show you here things you can do. So we have end-to-end flows. Each end-to-end flow gets one or more data sets from various sources. And then also we give some example data sources of getting ETH price data itself. You can get it directly from the Binance API. Of course, if you do that, it's specific to Binance. So what about getting from Kraken or something? If you use CCXG, you can get it then across Kraken or otherwise with a unified API. We also, Ocean itself offers the unified API across this as well, and it generalizes not just for exchanges, but for any other sorts of data assets. So it's a unified API. And finally, we also show getting data where it's using a feed from the graph, which is also HTTP based, but it's using JSON blobs to query and to get results. We also give an example of something that isn't ETH price data, but Bitcoin price data. And of course, you can get whatever else you want. You can get Twitter sentiment, whatever you want. These are just examples. Overall, there's many examples, data sources you can have that we show directly here, or that are given inside these end-to-end flows. But what we're going to do is here, we're just saying get data however you want. So I just showed otherwise. Going on to the next step, make predictions. Make predictions. The first thing is, build your AI model. Build whatever you want. And the main README links to some options. Like mentioned, we have some end-to-end flows. Each of those end-to-end flows builds some form of an AI model. Could be, simple linear regression. Could be something else. And then once you've got that model built, then you need a model to make future ETH price predictions. And that's what we're showing here. And the predictions ultimately are for this 12-hour period of 1 a.m., 2 a.m., 3 a.m., and so on, right? And the final predictions have to be here December 12th at 1 in the morning UTC, 2 in the morning, all the way up till 12 o'clock noon, 12 predictions total. So that is what we have here. And in our case, though, we're just going to use random numbers. So in the same Python console, with the random numbers, we're just saying we're going to have a mean. We're going to draw from a normal distribution with a mean of $1,300 and a standard deviation of 25.0. And then we just draw 12 data points from that. So this is just a very simple example of the predicted values. But of course, for fancier examples, end-to-end with modeling, we have the end-to-end flows, and we will walk through one today. Keeping going. Once you have your predicted values, what's really important is to understand how do you arrive at the error, right? And it's important to make a distinction between training error and test error, right? Training error is how well does your model do on the data it was trained on. But you could have 0% training error and have horrible test error, right? A good example is with the CARC tree. If you have a CARC tree, a classification and regression tree, you can train it such that it has 0 error, but it's just a decision tree, right? Whereas if you run that same CARC tree, if you make it such that it has 0 training error, it's going to overfit like crazy. And when you get to the test error part, it's going to have very high test errors. So the point is, training error isn't that useful. Although if you have super high training error, then your model's for sure going to be terrible. So you've got to have low training error. What really matters is test error. How are you doing on data that the model hasn't seen yet? By the way, I apologize for the sound. I can't control that background noise. So let's go to this. So first of all, what we need is, first of all, we'll set up a time range that we want to test for. And the final time range that you would put here is these times here, December 12th at 1 a.m., 2 a.m., etc. Right? But that of course, that time hasn't happened yet, right? So you need to have something that is accessible now. So here's a good example. What you do is you say, I'm going to pick the time now, but of course we don't have information about ETH price 1 hour from now. So we start with the time now, and then we're going to go 12 hours the past. So, sorry, 24 hours to the past. We could have gone 12, we're going 24 here. Great. So it might be, so that's going to be exactly 24 hours ago. That's going to be the start date and time. And then because exchanges give information every hour on the hour, then we're going to do that too. So we're going to take the start date time and round to the nearest hour. This is a function below in the helper function. Then from that, we're going to say this is the start date and time. Let's now have from that the first date time and then the next 12 hours. And that's what this does here. So it comes up with we've got the helper function that just does that. It's pretty simple, but it's nice to just have a single function. Finally, there's printing date time information. And it just tells you basically what times did you pick, what times you have. Okay, good. Now we have our target date times. We're next going to get information that's the true values. And we're going to use the CCXT library. We're going to grab from Binance. So by the way, true values for ETH price, I mean, there's no such thing as true. There's sort of like, what's the closing price in Binance on date and time X? What's the closing price in Kraken, et cetera, right? And they're all slightly different. So for truth here, what is truth on this README is Binance data. And it's going to get all the different prices, but we're going to be using the closing price. So here it gets all the data from Binance. It's set for the ETH USDT pair, and it's spaced by 1 hour. Then from this, we can yank out the closing prices. This is the times in universal time coordinate. Unix time, sorry. And notice we have the divide by 1,000. That's because of the convert from milliseconds to seconds since January 1, 1970. And then we get the values, and this is closing price. That's what this is about. And the details of this, CCXT has information, but we're just making it short and compact here. And then it tells you what you have. But of course, this is not just the last, this is more data than we want, right? We only want these 12 hours of times. This is actually more than that information, right? The information graph here. So what we need to do is we see, okay, let's line this stuff up. We have the target times. Now let's filter all of the times we got from the centralized exchange and the values, and just filter down to the values that we want, right? So basically, of all of these times and values, only keep the ones in the target. That's what this is about, okay? So now we've got the true values, the centralized exchange values, and above we have the predicted values, the ones from your AI model. With that, you can calculate error. So that's what this is, calculate NMSE, normalized mean squared error. The true values, centralized exchange values, predicted values, we calculate that, and in the end, we get the NMSE. And so we print that, and also to help with understanding, we plot the prices, right? And it shows the centralized exchange values versus time, the predicted exchange values versus time. And now, what we expect for competitors, you're going to iterate a lot back and forth on getting data locally, making predictions, seeing what the error is, looping, right? And to get better and better errors, lower and lower errors, maybe getting more data, maybe getting better AI model, better feature vectors, all of that, right? That's where the magic happens. But this gives you the baseline from which to start. Then, once you're satisfied with the accuracy, publish predictions, right? And if you want to have the most accurate possible, then you probably want to do it, 10 minutes, 1 hour before the challenge is due, right? You could do it, 6 days before, but your predictions are going to be much worse, right? So ultimately, you want to submit this 1 hour before it's due. However, it's useful to practice first, and it's okay if you practice beforehand. You just have to make sure that your final submission is the one that we'll judge on, right? That's what we'll judge on, is the final submission. So first of all, how do you save this? How do you basically make these predictions available to the judges in Ocean Core Team? I'll walk through the steps. First of all, save your predictions as a CSV file, and we make it easy here. You specify the file name and you save a list. Under the hood, this is 3 lines of Python code using Python standard stuff to save. And the CSV, of course, will look something like this. It's just like your list in a file. Then to put it online. And of course, you could have put it online in Google Drive or something, but the problem with that is that it can't be tampered with. So, for price predictions, we want to make sure that the predictions are not tampered with. Therefore, you're putting the predictions onto immutable storage, or Weave. And we have that where it's 1 line to do that, and that's how this works. So it's PyBundler is the wrapper for Bundler, which is the wrapper for Arweave, decentralized immutable storage. And so once again, you have the file name from above. We specify here just to make it easy to understand. And there's a single line in PyBundler where what you do is it funds and uploads. So it puts some money into your Bundler wallet, and just as much as needed to pay plus a bit of margin. And then it uploads that to Arweave, and it spits back the URL that it saved as. And so the example that comes back, the URL, it might look like something like this: arweave.net, and then this thing. And this thing is based on a hash of the content itself as well. So that's what it looks like. This is, even though this is arweave.net, you can actually access this information in many, many different URLs. This just happens to be one endpoint, but if you have this hash here, then you can use other endpoints too. Next, publish in Ocean Asset. So now you've got your CSV of your prediction. Awesome, great. Yeah, I apologize for the IT issues. I'm quite remote right now, and sorry for the noise too. I think I managed to chop down the noise a bit, but hopefully they'll leave it good. Okay, but there's an echo. Sorry. So yeah, first of all, just a quick review. You save a list as a file, then your predictions, then you save it into Arweave with the following line. You specify the file name, you specify that you're using the currency Matic, and then you give your private key. And what this does under the hood is it calls Bundler, which pays for your storage on the Arweave network, and then performs the storage, gets the file stored into the Arweave network, and it returns the URL. And the URL basically looks like this. This QC3 part is based on a hash of the content, and then the arweave.net is an endpoint. There's one of many endpoints because this thing isn't relying on just that. But in the end of the day, you have a URL, and you've got your file stored in a tamper-resistant fashion. The next thing is to publish the Ocean asset. So whereas Arweave is for storage of the file, Ocean is for data exchange. It's for sharing access to the file. And in our case, we want to be able to discreetly share access to the file to the judges. So that's what we're doing here. So the main call here is Ocean assets create the URL asset. You pass in the name of the asset. In this case, it's just ETH predictions and then putting in a random time, or the current time. Passing in the URL, which you got from Arweave up above. Passing in your wallet to sign the transaction. And then not waiting for Aquarius to metadata cache to update. You don't need that in this case, so we move forward. And then we also have it where we're specifying that metadata state isn't getting, well, basically by setting metadata state to 5, it won't show up your asset in Ocean Market. That way it won't get listed in Ocean Market directly unless you know the exact URI. So now basically you publish this Ocean asset. Now you've got it as an asset. And the way that Ocean assets work, you can do lots of things with them. You can, the core asset is a data NFT, and then it has one or many data tokens against it. Those are ERC20s. And so by default from above, you've actually got add data NFT coming out, add data token for that, and an asset, a DDO, which is sort of the metadata as a JSON blob. And so a data token, the idea of Ocean is that if you have 1.0 data tokens for a given asset, then you can share 1.0, then you can get access to that. So if I have published an asset, I have lots and lots of data tokens, I can share one or many of them to someone else, and then that someone else can download them. So what we're doing here is you are going to be sharing your data tokens, some of the data tokens to the judges. So what's happening here is data token.mint. So you're minting some data tokens and immediately sharing them to here. And this to address is a very special address. This is the official judge's address, right? So, and we're passing, it could be just one of them, but we're passing 10 of them simply to make it simpler for the judges to work with. And then you're signing yourself. So this is, notice how this is an ERC20 call, right? But because it's on Ocean data tokens, they are ERC20 compliant, then it's for now the judges will have access to that, right? So the judges, what they're going to do once they have this, I'm going to walk through what happens. They're going to load in their private key as judges, and then they're going to go through a bunch of steps to, at the end of the day, calculate the error and then see what your error is. What are those steps? Well, they create their own Ocean instance in their own wallet. Then they get the DID, which you have shared above. It's asking you, yes, write down the DID and data token address. You need to share them in the quest book entry, right? And that's important to us because by doing that, we'll know, we'll be able to line up what's in the quest book with what your submission is. And so here you pass in your DID from above. And then, so the judges will pass in the DID that you had shared. Then the judges, well, this is a key thing. The judges are going to download the file. They're going to take in the DID you shared, and they're going to sign the transaction. There's a lot going on here. The first thing it's going to do is it's going to order the transaction saying, hey, we want to download this thing, like we want to order it. And then second thing, and then an order will go through. Once the order is done, it's going to then take that order ID result and download the file itself. And in the end, it gets a file name. And then from that file name, the judges will load that file and get out the predicted values that you have, right? So this is predicted values. Then the judges will get actual ETH values, and it's getting it from here. It could have been from CCXT or from an Ocean asset. In this case, you're using an Ocean asset, which under the hood calls the Binance API as well. And once again, we get these timestamps, Unix times, and the values from the file name. And so now we have basically, we get all the data from the exchange this way. We specify the actual time that we want, which is December 12th, starting at 1 a.m. This is the start time, the next 12 hours. And that, of course, lines up with what the top has right here, right? So these things here, this is what your predictions have to be for December 12th at 1 a.m., 2 a.m., and so on. So that's what we have down below right here. So it's getting that. Then it's tacking on 1 hour in advance, 2 hours in advance, etc. And then it's filtering just like we showed before. But now it's filtering the actual data rather than from your testing and stuff, right? So now we have the centralized exchange values, the true values. We have your predicted values that the judges have downloaded that you shared. And from that, the error is calculated and plot printed here, and then plot prices. And that's what the judges will do. So the judges will do that for every single submission. And from that, whoever has the lowest NMSE, that will be the biggest portion of the results. You also have to describe your approach to some degree. And finally, so that's enough for a starting point. And then beyond that, to be considered for winning and for the 250 ocean reward, you have to meet these other criteria, right? You have to be doing better than constant and be doing better than any of our end-to-end examples, which are fairly simple. So it's a pretty low bar to meet. With that, that's the end of the flow. So to wrap up, to sort of conclude, what we did was basic setup, where you were setting up your installing the libraries, creating your Polygon account, setting your environmental variables, loading the helper functions, and setting up in Python for Polygon, right? The Ocean instance and the wallet. You were getting data locally, however you wish. The main README has links to that. You were making predictions in two parts, actually three parts. The first part is building whatever model you want. Once again, the main README links to some options, end-to-end examples. Then you run the model to make predictions. And in our case, in this example here, in this README, it's just doing run so that we don't get caught up in getting fancy here. And then key thing is how is the error calculated? And that's what's happening here. So that's the first part. And then the final step for you as a contestant is publishing predictions. Saving the predictions as a file, putting them online onto Arweave using PyBundler, publishing it as an Ocean asset to make them shareable, and then sharing them to the judges. And then finally, the judges will be grabbing your asset, downloading it, and computing the error. I will stop there, and thanks for your patience with our tech difficulties.
Awesome. So that was a very thorough README walkthrough. I know that we covered a lot of material in there. Does anyone have any questions yet? At this point, I'd like to open up the floor. If you do, just go ahead and unmute yourself. So with that, anyone? Egbert, Magic Thighs 911. I know we had another participant here. Any of you have questions so far?
On my side, I think it's very clear.
Awesome. I'd love to hear that.
I was just curious about the one of the criteria is on there being lower than the constant. Not totally sure what is meant by that. Could we get a little clarification? Maybe it's a dumb question. I apologize for that.
No, it's not a dumb question. So we want to make it where people actually try to build an AI model rather than just give a constant as a prediction, right? So, if I'm a smarty pants, I might say, you know what, a constant, I think that it's hard to predict the price of ETH, and it seems that, maybe everyone will have lots of trouble, so I'm just going to submit a constant and hope for the best with just that constant, right? And while we encourage people, we like it when people are smarty pants in general, like to be sneaky in results. That's often the source of great AI models. We want people to try harder than just putting in a constant, right? And that's why we're saying at the end, what's going to happen, we're going to actually see what the error of a constant is. We're going to try a bunch of constants and see what the lowest error is. And then same thing for the end-to-end examples. We're going to go and calculate the error for each of the different end-to-end examples. And by doing that, it means that competitors have to do better than that, right? They can't just have a constant. They can't just copy and paste one of the end-to-end examples. They have to do better than that.
Got it. Makes sense. That was kind of my main question of the whole thing. It was a really good presentation overall.
We're getting some positive feedback here on the README. JP is going to walk us through an example of how to submit a successful entry into the competition. If there's no further questions, Joab, do you have a question?
No, I'm JP.
Okay, sweet. So JP, I will hand it over to you at this point.
Okay, thank you. Share my screen. Okay, and so over here, you can see my screen, right? Okay, so the idea here would be, let me walk you through what is Ocean saying. Ocean is saying, look, the market is the way it is, the world is the way it is. You forgot the detail that we call data assets, and the assets are your assets. So what we're going to be trying to do here is run a competition that can help you. Notice that you can get the 250 ocean by making a valid submission. You don't have to win the competition. But in every iteration of the competition, you can actually become better than how you were before. You can actually make money from your trading. And that's what we're going to do and what we're trying to do, to show you our compromise with the value of data, understanding that data is an asset that you can actually leverage on, and that in the world that we live today, it's kind of useful to have another asset to leverage on. So the purpose of my presentation is help you even more with that. So what we're going to do is I'm going to walk you through a very detailed example of how to make a submission, so you don't have any doubts about that. And why are we doing this? We're doing this because in the previous competition we noticed that people were making obvious mistakes that were completely unnecessary to make. There were doubts in the submission, there were doubts on different areas, and we thought, look, we are actually helping people. Let's help people more and help them get a right submission. Doesn't have to be a sophisticated submission. You can actually make it more sophisticated in the next edition. But by the next edition, you can actually have more ocean tokens and also your own trading strategy. And you can see other trading strategies and how other people are doing and everything. So don't measure this as if you win or lose the competition. Compete against yourself. How did I do in this edition? How can I do? How can I improve my model in the next edition, for the next edition? And for that, we're going to start with a very, very simple thing that like the baseline, so to speak. How does a very, very basic submission work? So we're going to go to here. This is the main README, and here and you have here the link, gentle introduction, which essentially is this bare bones thing. And we're going to walk through this in detail. Okay, you have here some instructions. By the way, this is normally our examples you see are quite elaborated, have different advanced models. Not this one. This one has repetitive code. It's not, don't repeat yourself, and it's neither of those things. Here, what we're trying to do is to make sure that we leave no doubts. You can hear me, right? Because I heard the sound. Make sure that we hear that there are no doubts, because doesn't it, it's not very pleasant when you're reading something, from instructions from a competition or something, and people say, oh, this is super easy, and they just write a line in there that does not work for you, and then you don't know what to do. So we're trying to solve these kind of problems and make it even easier. Okay, so remember that at the end of the day, the magic comes from you. Some people might think that the price of Ether is determined by the price of other tokens, or the price of gasoline, or the price of whatever. In this example, we're going to go through an hypothesis, which is, we say the price of Ethereum is Ethereum is a technology, so maybe technology stocks have an influence on the price of Ethereum. Can help us explain that. So what is the competition really asking you to do? The competition is telling you, look, there is this thing of the price of Ether, that we don't know it right now, but we will know it for sure in the future. And we want you to build a model, build some variables that can help you predict what this price is going to be. And the bad things about these models is that they all come with an associated error, and the error actually can distort quite significantly your results. So what we try to do here, just to summarize, is understand that you have an asset, you have your brain that is a super asset. You can leverage on both to get data plus brain plus improvement in every edition, and help yourself and help other people actually navigate through these markets and this world in a much more nice way. Especially for the things that have been happening recently. So let's start. Remember, this is a very, very basic thing. So I'm not going to type it because the idea is not to be here until tomorrow. But here you have a detailed explanation of absolutely everything that goes on. So the first thing that we're going to do is create an environment. This environment, all it does is I always forget the trick here. This environment, what it does is it creates like a container, like an isolated area Okay, so we can actually install things in here and tweak things in here and not affect the rest of the system. This is important because you want to run different models and you don't want to get your results altered by things that are in the environment that you were using. So that's an important part. We're going to activate the environment. We're in a Linux system, so we're going to use this line. If you were on a Windows system, you would use this other line. Sorry, and then we will install these libraries. We're installing pandas, which is the main library from data science. Think about an Excel spreadsheet. This is the equivalent version, and CCXT, which, as Trent has explained, is a library to get data from different exchanges. In this particular case of Binance. And for the model that we're going to use, the algorithm, we're going to use a regression, a very simple regression, and for that we will install a scikit-learn, which is one of the main libraries for that. We already created the file, so it's so we are you have the file created here. Is the only thing that I did kind of automatically to for the sake of time and because creating file was not really that much interesting. But the first thing we do is import the libraries, and you have classical libraries in data science, again, pandas, the Excel. NumPy is for manipulating arrays, is an advanced array library. Datetime and time, CCXT I mentioned, and these three are the ones from scikit-learn for the regression that we'll see later. So far, so good. Now, we have a problem. The problem is we need to get the data to test our hypothesis. In our example, we're saying, okay, we think that some technology stocks are actually going to be a good predictor of the Ethereum price. So we need to get this information from these technology stocks, and there are several ways to do it. I'm showing you two here in the CCXT library. We are gonna use this to fetch data from Ethereum, USD, which is the measure for this competition. But also, you could change the ticker and use any other, for example, cryptocurrency or any other exchange to fetch data here into your model. Okay, the one that we are using in this example is this one that is actually quite a new one and has information from the stock markets. And in our case, we're going to get information from 4 particular stocks that are Tesla, Amazon, Google, and Apple. Right. This one has very interesting things that includes, for example, market sentiment, and it has a particular feature. I'm not going to show you this right now. And by the way, I'm not affiliated in any way with this company, but includes market sentiment for blockchain, for example, or for different technology stocks and everything. So as you can see, I mean, here we run numbers, but there are many things you can run into your model to make your model more predictive, right? So in our case, we're going to go into Ocean. I already did the work for you, and I got these 4 stocks. I queried them, just for the sake of time, and we get the information here. By the way, this is free, so you are not going to have any problem with this. So we download the asset. In a second, will be downloaded. We have it here. Download the asset and extract, in this particular case, the 4 stocks that are in CSV files. And we got them here. Okay. Now, if you inspect these elements, you're going to see that this is just the normal information that you would get from any stock price, like open, close, and things like that. We're going to explore them in a second right now. So, you hear me? Hello? You can hear me, right? Because the computer did something. Sorry. So we got this. Okay. So let's open it up. Now, remember that when you get data, the world is a messy place, and data is going to come really messy. It's never going to match. There's going to be, there are going to be rows that were supposed to be there that are not, variables that are missing, outliers, all sorts of things. Okay. In this particular case, this data is quite prone already, but you might have other data that you will need to work on to make it feasible for this. And we're going to copy the first example, and you're going to see what we do here. In the first line, the one over here. We're just going to open the CSV file. Okay, this is a super frequent function that we use in pandas. And here is where our strategy begins. You see here, we need data, but we need data that can be grouped and compared within each other, because you need to have some sort of normalized data to run anything. So we're going to use time to compare the data. And the problem with time is that if you want to compare time, you have to make the computer understand what time is it in a way that is common for all the data. So luckily for us, computers have this system, in different ways. You can do it with timestamps. You can do it with objects like datetime. In pandas, for example, you can do that with this particular function here, which is to translate data into datetime. So in our case here, what we do is we just open the CSV file, we rename the columns, okay, and we give format to this data frame. So let me show you. Let me show you what will happen here. And I run this. I have all the data here that we have from the stock market, open, high, low, close, and volume. But if I ask for the types, I get data. And this is important because if I comment this line, for example, and I rerun it, I don't get data. I get object. Object is the excuse that Panda has to say, look, I don't know what number is this, so I know it's some number, so we're going to call it object. And the problem is that if you have a lot of objects, then you cannot compare objects, because in reality, the computer is really telling you that it doesn't know what object is this. So by running this with datetime, you can actually compare dates with in an unequivocal way. So it doesn't have any problem for merging the data later on. And this is what we do with one of the stocks. I'm saying that the Apple stock is a predictor of the Ethereum price. Okay, and I'm just going to copy this, but this is a copy paste exactly of what you will get. What you get from Apple, but instead of Apple, this one is for Google, this one is for Tesla, and this one is for Amazon. But it's exactly the same thing for the three of them. Okay. So I'm just going to copy this, and we get our data. So now we have like an equation, right? We have the Ethereum price, we still don't have, is equal to a whole bunch of information from 4 technology stocks. We need to get the Ethereum price. We need to have like a balanced equation. That's what we need to run our model. So we're going to use the CCXT package, as it was mentioned before. You have here all the documentation of the CCXT package, and in particular, this function here is going to give you for the ticker that you select, the symbol in our case is going to be Ethereum USDT. It's going to be Ethereum USDT. The interval that you want, in our case, is 1 hour. Remember that this competition is predict the Ethereum price per hour. And the since is the time. Okay. Now, there is a limit, but the limit, if you don't write it, you don't have to, because it has a limit of 500. So this gives us the first problem, which is, for the amount of time that we need the data, we're picking like a couple of months, we need more than 500 rows. But this limit is 500. This is specified in this library. So we're going to have to query this library several times to get the information that we need. And we're going to have to merge all this data at the end. So that's the thing that I was mentioning to you before about coming from a messy place. Data has a lot of problems, and you need to homogenize all the data before running anything. So here we get another restriction, which is this time that by default is undefined, but you can specify here a particular date in the past, has one characteristic, which is you cannot pass the date time that we normally use. You have to pass date time as a timestamp, like the Unix timestamp that started in the 70s and all these things. It goes by second or millisecond and stuff. So we have to find a way to translate that for the computer into that from a date that we are familiar with. So in this case, we are starting with our first chunk of data, our first 500 are going to be coming from the 9th of August. We're going to translate that into a timestamp, those just a line of numbers that for us is not easy to recognize the what time is it. And then we have another problem, which is this library is asking us to, let me show you. It's asking, let me do this one first. Let me do this second one. We're going to see what happens. By the way, if you have questions during the presentation, please don't hesitate to ask, because we're going through a very, very simple example that we want to establish as a baseline. And you're going to see that in future workshops that we're going to be running, we're going to go incrementally making more and more sophisticated examples. The idea here, again, is what I mentioned before, which is don't measure this as I want to win the competition. Measure this as, wow, in 6 months of time, I've learned a whole lot of trading. I now run my own models. I can now read other people's models. I have valid submissions. I've done something positive in a very uncertain situation. So it's a very valid proposition. So that's what we're trying to do. So this is what we have. See, believe it or not, this is the seconds since 9 of August 2022. Okay. Now, we have a problem here, which is this library only accepts integers. It does not accept decimals, what we call float numbers. And also, you need to add the millisecond in this time. So that's what this line here actually does. It just adds milliseconds, and it forces this number to become an integer. Like remove the commas, like or the dots. That's what it does here. And that's what we're going to do. It's like a very standard thing. So let me put this a little bit up so it's clear for you. And we repeat the same thing. Sorry, we repeat the same thing. We just run the function now. Let's see what we get. We have all the data. Okay. Now, this data is not exactly what we can still work effectively, because it's the same information that we have before with the stocks that you've seen. See here, we have the timestamp, we have the open, the close, the high, the low, the open, the close, and the volume for the day. But we need to put it in a way that can be compared to the data that we have from the stocks. Okay, so we can run our algorithm. So that's what we're going to do. I mean, we first create a data frame with this. We call it the first 500. Essentially, all that this thing does is it shows you exactly the same data, but in a pandas data frame, which is a very useful tool to manage your data and to see what you're actually doing. You see, it's the same thing, but now you have the timestamp. And now we have this 1, 2, 3, 4, 5 that I don't remember what it is, but I can see in the documentation what it serves. And I have here a line that actually will tell me, how can I rename the columns so I can understand what I am looking at. And this is what I'm getting here. Now, we still have one problem more to solve, which is in the stock from Apple, Google, and all these companies, we have here a date time. And here we have a timestamp. So we cannot compare these two things. These are two different things. The computer is not going to know which one is equal to the other or larger than the other and all those things. So that's what we're going to do next. We're going to convert this Unix time provided. That is, remember that it comes in milliseconds because we had to ask for it in milliseconds, and it is going to come back in milliseconds. And that's what we're going to put in here. And the last thing we're going to do is we're going to rename the column, because now it's no longer timestamp. We're going to call it what you have here is exactly the same information. but much more easy on the eye, right? I mean, you have the date, the open, the highest, the close, you have all the data. You're going to see that we're going to end up with a huge chunk of data, and then we can run an algorithm model to see if we are correct or not, if the stock prices of these companies actually predict the value of Ethereum per hour. I'm going to copy this, but as you can see here, what you have here is one step after the other, exactly the copy-paste that you have in here in detail. Exactly the same thing. Doesn't change anything except the date. Because we compute since the 29th of August, then 18th of September. So every 500 hours, we change the date and we get the next chunk of data. So we can have all this data for our model. Okay. So far, so good. I mean, that gives us the whole number of files that contain information from Ethereum. Remember that this data is important. I heard, is there a question or something? Are you all good?
I think we just had someone join the meeting. Welcome, Mats.
Welcome. So what we have here is the 5 chunks of data from Ethereum. Remember that this variable is particularly important because that's what we use, to determine the winner of the competition. But it's all in different files. We cannot run this. We have to merge this, So that's what we're going to do next. All we do next is with this very simple line in here, we concatenate, we just add, these pieces of data, call it Ethereum price. So Ethereum price now is going to be division of, it's going to add one after the other. That's concatenation. One after the other is going to add the information that we had, and that's exactly what is going to deliver to us. Now, we are still going to run into problems because, as you can see, there are 2,200 rows. This is the data set of Ethereum, but stocks don't trade all days of the week, and stocks don't trade depending on the hours of the day. And here we have a crypto asset, Ethereum, that trades every day of the week and at all hours of the day. So we have to find a way to reconcile these things as well. So let's see what we can do. First thing is, let's prune this number, this table, to get to what we look at for the competition. We're going to remove these columns, the open, highest, lowest, and volume. And we're going to leave the close column because remember that, we measure what we call the true value, which is not really true, but is the one that we have decided for the competition. That is the close value in the last minute and second of the end of this particular hour. And we rename, the close Ethereum price to be clear on what we're talking about. Don't underestimate renaming columns, because at the end you're going to see that we're going to have a very large data set, and renaming things is going to help you quite a bit to see what are you doing and what kind of data is that. So the last thing we're going to do is we're going to sort the data to have it in the same order that it was given to us for the stock market, and we reset the indexes, which in this case is not really particularly necessary, but we do it just a formalism for pandas. And we get our final numbers for what we consider the Ethereum price. Sorry, this takes a while. It's making the queries, and it has to make 5 queries, so these are the numbers. Okay, see, we have from the 8th of August to the 5th of November per hour, per hour, the price of the close of Ethereum. Okay, you can see here is this number here, is this number here. Remember that we switch it, okay? we sorted that, and that one here, that now is the first, is the last one here, so it's in the same order as we had it in the stock market. Okay, so now we create what we call the base data frame, which is, okay, now we have, think about it, we have a whole bunch of stocks. We have Google, we have Tesla, we have Amazon, everything. And we have, on the other hand, the final data from Ethereum. And we want to put all these into one data set so we can run algorithms and things with that. Okay? So that's what we're going to do. We're just going to put this together. And for that, we have a very effective function. Let me copy the 4, but I'll walk you through in detail. To do this, which which is we're going to merge. The first one is going to be the Ethereum price, and we're going to add the stock of Apple. Okay, so let me show you what will happen. I just do this. By doing this, I'm going to get the first column is going to be the Ethereum price, and then I'm going to get all the columns with the open, high, low, and close and volume of Apple. You see, that's why we renamed these columns before. But then we will have the Google, we will have many other columns that you can get from many different places, and you need to know where this come from, so you know what you're doing with your data and your analysis. Also, the other thing is that we no longer have 2,200 rows. Notice that we now have half of it. And why is that? Because we specified here that we only want you to match dates and times that are equal. And that's why we went through the hassle before of transforming the data types to date time. Because all the data that we have has a date of date time, now the computer knows how to compare this. Okay? And if data will be in different formats or will be not defined, the computer will tell you, I cannot know if this date is the same as this other one. So by making sure that we can compare with date and making sure that we have everything homogenized, we have a very consistent data set to run our numbers. So if I add the rest, which is all I'm doing here, nothing really particularly interesting. If I add the rest, that's what I'm getting. The entire data set that consists of all the rows. Notice that we lost 2 because remember the world is an imperfect place, and some of these stocks might be missing one day, and it's actually a trading day. It's just that something happened in some system, and that day did not get recorded, and it's considered a missing value. But we now have, this is you have here 3 dots, but you have here a very very long table with all the columns. Here you have Apple, then Amazon, and then you will have all the rest. So you have a very extensive data set to work on to make your predictions. Okay. Remember that to be able to make a valid submission for this competition, you can use this example as a base model. And if you just think about different variables, which is the good part of this, we want to see your magic. We are using here data from technology stocks, but you might have much better ideas than us. And that's the point of this competition, that maybe there is super counterintuitive data that nobody thought about, but that you can actually leverage on. You can actually submit to the competition and create an asset for that data. You have assets. An asset is a thing that gives you good things in life. That's why at Ocean data is called asset. And it's an asset that at the moment you have underutilized, and we are trying to help people and help themselves do this. Sorry for insisting, but it's like an important point. So let's explore a little bit what we have. Here we're going to see something that is important, and that is, okay, now that I have this, I make sure that every column has the type that is going to be useful for my model. For example, I'm going to give you an example. Say that in this column here, the price of the open of Apple, you see here numbers, and I see here numbers, but we don't know if the computer considers these as numbers. So we need to make sure that the computer is actually considering these as numbers, because it might be considered as a text, and we just don't see the commas or the double comma or something. So we need to make sure. And how do we make sure of that? We have this function that helps us explore the data in detail, and helps us see that we are actually on the good track, that we have numbers, and that the numbers are what we expect. So you see, for example, remember we had our date, that's in date time in all. And for example, the Ethereum price is a price, is 1,000 and something. So we expect it to be a float because it's a 1,000 comma something. Okay, the volume is provided as an integer. It doesn't have commas. That's why the computer considers this as an integer. But as you can see, it is consistent all around. So that means that we can actually trust that the computer will understand what kind of numbers do we have here. Now I'm going to tell you something I'm going to show you something that maybe it's going to make you think a little bit about who says what where. Because another thing that you can do to explore data is to just run the correlation between the data. You know, the simple relationship between variables. Now that we know that we all have numerical data variables, we can actually run the correlation with this. And if you run the correlation with this, you start seeing funny things. You see, for example, look at this. The Ethereum price has an 81% relationship with the Apple stock open price. Okay, but it has a negative one, all throughout. And maybe you have heard in this interview the CEO of Binance, Cizi, mentioning that the price of assets, of crypto assets, and the price of the stock market it seems to be highly.
Looks like JP, his connection just broke off, so we'll give him a second to jump back on. Any questions at this point based on his presentation, feedback, either positive or negative? I'd like to open the floor. So far in the presentation, we're talking about cleaning up, ingesting and cleaning up the data to correlate or to find correlations between common stock, very large market cap stock prices and Ethereum close prices. If you guys have an opinion, for example, if that correlation is going to be strong or not, before we see our final results, what are we thinking so far?
Be interesting to see. I don't have any predictions.
I'd love to see some maybe in the future examples. Like, I totally agree that in some way the stock market is influencing directly the prediction of Ethereum and so on. What I think is that maybe the social media influences a lot the way the pricing are going up and down. So at a future point, I'd love maybe to see if, I don't know, somebody from community or ourselves as well in the future predictions will use something like a Twitter scraping or other social media platforms to predict the price of the Ethereum. Just some thoughts on this.
Yeah, it would be interesting because the correlation with individual stocks and the price of Ethereum, I'm not so sure. I haven't read much about, but I have seen the correlation between like the S&P 500, an index, and the price of the cryptocurrency as a whole, like whether it be Bitcoin or Ethereum. They seem to track pretty well, especially in an environment like we have right now. That seems to be a big indicator of overall market trends.
Yeah.
It'll be interesting to see what JP comes up with as far as his final result. Of course, I've seen different correlations for crypto price data, sentiment analysis as well from Twitter being very helpful, at least in showing volatility. Maybe not movements up in one direction or another based on the natural language processing, as the sentiment analysis at this point probably isn't super sophisticated, but definitely tweets from, like, for example, like Mr. Whale or Crypto Whale accounts on Twitter would indicate like large volatility in the large market cap crypto prices, Bitcoin, Ethereum, for example. So some of that is definitely occurring already. But predicting, I just want to give my 2 cents here before JP signs on again. I've read an article about sentiment analysis on Wall Street Bets, which, by the way, doesn't allow really direct conversations about crypto. Wall Street Bets sentiment analysis, you can search for the words bear and bull in the recent posts from Wall Street Bets, and actually predict with some accuracy the movement of the stock market based on those 2 terms. And so it doesn't have to be very sophisticated natural language processing, but there is some truth to this sentiment analysis that would be really cool to see applied also in crypto.
Yeah, I think that definitely you will see that there is a significant correlation between whatever you get from the sentiment analysis and what is happening in the stock market. You have personalities making comments in Twitter, like Elon Musk, that will move the things widely. So I will not be surprised to see GP showing that the stock market have a correlation that is significant. Whether this is going to be enough, probably it's not the case. There is another variable that is actually the price of Ether itself. That it's the price of Ether. I don't know if one is going to talk about this, but the signal is highly autocorrelated, which means that if you look at the past of the signal, it tells you something about the future of it. And it's basically a consequence that you cannot have instantaneous changes in the price. Right? So the signal is going down, it would probably continue going down slowly, then maybe move up, but it doesn't jump. At least not most of the time. So the autocorrelation of the price for Bitcoin, Ethereum, and most of the crypto currencies that have a high market cap will tell you a lot, and it's probably gonna have a more significant effect than you get from the stock market. They are not, one variable doesn't discard the other. You can start getting different pieces of information from each one of these. So autocorrelation, stock market, the sentiment analysis, etc. All of these variables are definitely going to help to have a better prediction of the prices.
Definitely like where this conversation is going. I would like to give JP another 3 minutes to 11:30 to see if he can conclude his price prediction of ETH. In the meantime, let's keep going on this discussion. I definitely think that we have the ability to predict the future somewhat based on past events. Of course, that's the point of this competition. I'm reading a great book on this called The Man Who Solved the Market regarding the stock market, who believes that there are 8 different states. Oh, JP, you're back. Awesome.
I was talking alone for that long.
Yeah, the stream concluded and we lost you there, and we are glad that you're back. Can you go ahead and share your screen again? We're all anxious to see the results of your algorithm here.
Where did you get lost? Come on, I've been talking alone all the time. I can't believe it.
Discord hates you. Or us. I don't know.
What did you lose the connection?
You had just cleaned up the data for you've just cleaned up the data frame to remove the open, high, and low from the Ethereum price data, and then you were getting to the Tesla, Apple, and Google and Amazon stock price data right before predicting the correlation.
No, yeah, lower. There, like
around here, right? Yeah. So
yeah,
somewhere.
Right.
So no. We heard the merging of the
So you
data sets, and we lost you after that. Yeah.
Oh man, I mean, I killed it. I gave a super good explanation, and I was alone. Okay. So let me continue. Well, all I do is run a linear regression, and and I add here, the idea here is a very simple regression. So you have, on the left side of the equation, the Ethereum price, and on the right side you have all these variables, to predict the price of Ethereum. You there? Yeah. Oh.
Yes, we're here.
I mean, it didn't make any noise. I mean, I can't believe that I lost it. Then all I do here is to separate the data set into a portion that I'm going to use to run to test, to optimize the model, which is essentially what this thing does. Okay, and it just trains with the data. Again, this is a very simple algorithm, and then it delivers the predictions of the. Let me show you this. So delivers the predictions. And you can see that it's gonna deliver like a bunch of predictions. So I normally limit this to the first 12 predictions. These are the predictions that the model is delivering. So this is actually the values that you should save on a CSV file and submit to the judges, as it was explained before. And then you have here the R squared, which is not something that we look for in the which is how much, what percentage of the variance is explained by the model. In this case, it's 70%, and the NMC, which is the associated error, normalized. In this case, it's still high. This model is not very good at predicting, but the idea of the model is to give people ideas about how to, use other models or maybe use other data, find out that they have actually an asset that they can leverage on and that it's currently underutilized, and that they are, better than how they were a few months ago, and they have some ocean for making submissions, and at the same time they have assets that they didn't even know existed that are actually serving them, which they make a good competition. So it's not really about winning the competition; it's more about doing better for yourself, kind of thing, and comparing yourself for how you were like 6 months ago, so to speak. And that's the idea of that I wanted to transmit. But I feel so sorry that it got. I lost the connection. Hello, you there?
Yeah, no worries on the technical issues. I think we can all sympathize because everyone has had technical issues at some point or another. So I'd like to open the floor to feedback or questions about the algorithm, questions about how to submit, for example. And remember, again, the deadline is December 11th. At midnight UTC. So who wants to comment on this algorithm and the correlation of 70% and the error rate of 14%, for example?
We discussed, JP, as a context, we discussed a bit about the algorithm while you were gone, and how the stock market influences. So probably that's the reason why we don't have additional questions at this point.
And also because I was super clear and super understandable, and thereby nobody.
Honestly, yes. I really like the gentle presentation and how you walked us through all of the lines and all of the commands that you had to do and the logic behind the doors, not just like some things, some commands that we run in the terminal or whatever, but more like, why do we do these things? So I really I really liked the way you approached this.
Just regarding the error rate, this is an example of how the things could be done, and definitely it's just there for the purpose of showing how to do this. But we also include in the templates examples of using algorithms that are slightly more elaborated, including using random forests, neural networks, etc. You can find all these in the repository for the ETH prediction, and it's made in a way that you can, for example, take what Pablo has been showing and then just place the new model in the middle. Of course, depending on the type of data that you have and whether the algorithm can model linear relationships or non-linear relationships, you should expect improvement in the prediction. One of the algorithms that you will find in the README for the data and the moment that they were trained were giving results that were as low as 3% in the prediction, which is a good starting point. Start tweaking, making changes, and enhancing it.
Yes, I mean, that's totally correct. I mean, the purpose of this example is just to make a good first step, in something that has very understandable approaches. But then you, of course, can become really sophisticated, and there are other examples in the READMEs where you'll find very much more elaborated models. Also, you will also find much better code. This code is very repetitive and is only for instructional purposes. Yeah, I mean, totally agree. This is like the bare bones. At the end of the day, remember that what counts is that your predictions are accurate. I mean, it's so that in mind. But yeah, I mean, this is a super simple example, so absolutely everybody can give it a try. It's a very reasonable confidence that it's going to get to a final model that is going to be able to submit. And after that, once you've done it once, second time is easier and it gets easier, and you come up with ideas and models, and there are other READMEs.
Awesome. Well, thank you so much for that really cool example. And Trent's not here, but thanks to Trent, we have a very clear understanding of the README as well. I want to thank Egbert, Magic Thighs 911, and Mats for sticking around for most of the meeting here and for your participation as well. So with that, let's conclude, and happy trading, guys. Happy predicting. See you later.